Good morning, guys. Today we'll be dealing with the next topic of units and measurement. I hope you have understood till precision and accuracy. Right. So what was precision and what was accuracy? You can understand by looking at the numbers of or by looking at the values you chart when you're taking the readings during an experiment. That is where the precision and accuracy comes up. Right. So next topic which we are going to do today is errors. Okay guys, and again, just like us, every video will have a small chat. So during the live class, I don't know whether you will be listening to this audio, this video class after the live class or not, but during the live class we'll be covering the least amount of topic, because sometimes there can be any problem during the net, right? We are just human beings. It's not in our hands how the video will, how the net will be there, so some errors can come up. So that's why I have decided to take least amount of topic during the live class, and most topic will be covered during the video classes, right? So I'm extremely sorry if something happens during the live class, right? And the live class topic will be explicitly different than that of the video class. There will not be any continuation, right? Because I cannot foretell what topics will be finished during the live class. That's why. So let's move on with the topic, which is errors. Very, very important topic, guys, and it carries a lots of mark from this chapter. So let's move on. I'm going to put out the light. So what do you mean by errors? Right, that's very simple, guys. You know what is error, that is where something mistake. But in physics, errors is also just like mistake itself. But see, suppose I went to a shop and I wanted to purchase a pants, right? And this is a waist inch, right? That's how you get. Suppose the waist inches is 34, 35, 34, 36. It's an even number, 38. These are the inches, but actually your waist inch is around 35.7, or let's say 35.5. This is the inch of your waist. So that is not provided by the company. So what would you do? You will say that it's okay, you can either give me 34 inch what I would say pants, but it will not come. I will squeeze myself and I will put the pants. Or I will say you can give me 36 inch of pants, and I will just use a belt, and I will strengthen, or I will fasten it so that I can use it according to my waist size, right? So that means the measurement can be, or the pants can be of the size 34 or 36. That is, this is my actual measurement, right? It is 35.5. That is my actual measurement. But I can use a pant which is of 34 inch, or I can use a pants of 36 inch. So it is 0.5 less, 0.5 greater. So my pant size is either 35.5 plus 0.5, or it is minus 0.5, right? These both the pants I can use, and this variation of 0.5, this is known as error. I hope you understood. Clear? This is called as error. So any measurement or any values, or if suppose this is my length of a cloth, this measurement when I am taking, right, the actual measurement I'm not able to take the precise measurement. So there will be some of the reasons, or due to any reason, the reasons will be listed out later on, guys. So due to those reasons, the measurement will be having a plus or minus variation. That is, maximum value that can be taken will be different, and there is a minimum value which can be taken. So any measurement can be written as, see, if this is A, right, that is the actual measurement, real measurement or real value of that object, or true value of that object, is equal to measured value, right? Measured value plus or minus error, right? This is a concept. So any real value or a true value of a measurement or of a device is equal to the measured value, what you measured, plus the error, or it might be minus the error. Suppose I had a scale, its actual length is 2 meter, but what I measured is only 1.8 meter, so the error is of 0.2 meter. Similarly, the same scale I might have taken the reading as 2.2 meter, so the error, right, so the error is, again, it might be 0.2 meter, sorry, minus, right? So minus 0.2 meter is its error. Clear? So any number or any calculation is always written as sum of the measured value plus or minus error. The error can be greater or it can be less. Either way, right? So it is clear that any measurement or any device you take, suppose, see, just like the previous day, suppose a company releases a pen, it has, they say the length of the pen is, say, is 31 centimeter, but while we measure, this measurement which we are taking can range from, I'm just giving an idea, suppose it can be a 2.8 centimeter, you measured like this, another person measured like, suppose it is 2.9 or 29.3 centimeter, right? So there happens a mistake in the calculation while measuring this pen, right? So this 31 centimeter is true value of the pen, and these two values are the measured values with some errors. So different types of errors are there, and they are broadly classified into three parts, which is systematic errors, then random errors, and the last one is least count errors. So systematic error, random error, and least count error. Least count you might be knowing. I hope you have seen vernier caliper, etc., the devices which are used for measuring very small length. If you have not seen, you might be seeing during your 11th class, that is this year, right? So what do you mean by systematic errors? From the name itself it is clear, the thing which you guys rarely do. That is, you guys are not doing the things in systematic way, right? I have noted that only one child is submitting his notes and works regularly, and now I think 2 or 3 years are also coming up, yet complete students are not coming. And previous live classes also I heard only 5 or 3 children attended it. I don't know why you guys are not attending the class. Once you miss the live class section, you are not going to get it back, guys. Okay, so systematic errors. These type of errors are done in a systematic fashion, or I can say which is something which you know, right, and it can be predicted. Hence, it can be easily eliminated, right? That is, I hope you have ever heard about zero error. Zero error. See, while you are measuring a weight, right, you stand on a measuring gauge like this, right? There will be a dial. So before standing on that, you are supposed to keep the zero, right? This is 0 point. Let's say this is 0 point. Has to be meeting with the 0. There will be a starting point like this. This pointer should be initially at 0, right? Then only you are supposed to stand over it and say, well, what is your weight? But suppose the same gauge, before you stand over it, the pointer, this is at 0, but the pointer is keeping like this, right? So that means the 0 is not met, right? This type of error, and it's like an instrument error, but it can be adjusted by you, right? First time you looked at it and you saw that the 0 is not met by the pointer when there is no weight over it, so you understood there is a mistake. That is known as zero error. So you could predict it, right? So once you predicted, you corrected it. So that type of systematic or errors are systematic in nature, and you can understand how predictable it is and how it can be rectified is known as systematic errors. And the first one is instrument errors, just like this. Zero error is an instrument error, or you can say another instrument error, what you know. No, because of the errors in the trials. You are almost going to suppose, let's say, calibration, right? Suppose you are having a watch and you are using that watch to to see the time. So sometime you would adjust, or else by some fault the time is showing 5 minutes late or 5 minutes early. So that is an error of the instrument which you deliberately kept, right? So those type of errors of the instrument is known as instrumental errors. That can be corrected how? If you see that it is 5 minutes late, then you just have to adjust it and make it 5 minutes earlier so that the time comes correct, right? Similarly, personal errors, that is the second type of systematic error. So first systematic error is instrumental error, and the second is personal error, right? That is because of your judgment or your or any observer's judgment. See, suppose the observer, he is not looking at the values, he is not looking at it in a proper way. Just like our best example is parallax error. That is, you are supposed to look at a pointer or a measurement in a straight way, right? This is your pointer, you are looking at it straight. You are not supposed to look in either direction. So this is known as parallax error. So this is an error which is made by you deliberately. Those type of error which is made by you is known as personal error, right? Clear? And third, and personal error, similarly the third section is imperfections or in experimental technique. No, sometimes that you do in chemistry, right? See, you will be asked to take 10 ml of any liquid and should be added to only 5 ml of another liquid. Sometimes by small mistake it will be 9.8 ml and this might be 4.5 ml, like that, right? This is a very small change because you are human being, right? So this is an error in experimental technique. This much is clear, right? So first systematic error is how many types? There are 3 types: instrumental error, personal error, and then the other is imperfection in experimental techniques, right? The notes I will try to send you by the class notes. I will try to send it by the classroom itself, guys. But while listening to the class, please write down the notes by yourself. That is a backup for yourself. So the next type of error is random error, right? Random error means it cannot be calculated. It is caused by chance, without any specific reason, right? We don't know why it is happening. That is like earthquake, right? Suppose I was using a meter scale and I was measuring, or a pointer was like this and voltage was being calculated using a voltmeter. Suddenly the earthquake, the pointer will be showing something else, right? So this and all are random errors, or I can say accidental errors, because I don't know why it happened. Temperature fluctuation, right? Similarly, some fault, nature's problem, right? Those type of errors is known as random error. The last type of error which we are going to deal is least count, or LC. Least count error means, see, suppose I consider a small scale like this. Say it is of 10 centimeter length. So it starts from 0, ends with 10 centimeter. So between 0 to 1 mm, 10 divisions of 1 mm is there, right? 10 divisions of 1 mm. So 1 mm is the least count of my scale. That is the smallest value that can be measured by any device, is the least count of that particular device. If another device is there and if each division is of only 0.5 mm, means 0.5 mm is the least possible value which can be measured by the second device. So that is the least count of the second device. I hope you understood. So I can say how much decrease the least count is, that much precision of that material is, or that instrument is, right? So if I am having 2 devices, right? I have 2 devices here. One is having least count of 1 mm and the other is having least count of 0.5 mm. Which will be having higher precision? I said this one is having higher precision. So if I have a length is measured, see, length is measured, the first scale of 1 mm measurement might be 1.1 mm. Length is measured by the first ruler. Second ruler, with this having 0.5 mm, I would say least count, will be having, or can show the second decimal also might be, right? So this is, which one is correct? Both are correct, but second value is precise, right? So For me, there is a small error shown. There is no second place decimal here, but there is a decimal place here. So this is showing higher precision. So I can say there has been a small error while using the first instrument. So this type of error due to the mismatch or due to the variation of least count of an instrumental device or an instrument for measurement is known as least count error. This much clear. Now we are going for, so I'm just going to brush up. So how many type of errors are there? Systematic errors, random error, least count error. Systematic errors are those errors which can be predicted and hence can be eliminated. Right, and the example I told you about zero error. Right, that is you are using a weighing gauge for measuring your weight. Before standing over it, you have to see whether the pointer is coinciding with the 0 point. If not, you have to adjust it. Until and unless it coincides with the 0 point of the measurement device, you cannot stand over it, because if it is not matching and you are measuring your weight, it will be showing an error. Clear? Next error type of the systematic errors itself is having three types, which is instrumental error, personal error, and imperfection in experimental technique. Instrumental error is due to the problem of the instrument itself. Suppose you are considering a watch, or you are having any device and it is calibrated wrongly, that is, it is tested wrongly, and because of that wrong instrument, the readings which you are going to take is wrong. But you know it is wrong, so you can take it, or you can correct its imperfections and make it good. Right. So now second type of systematic error is personal error, which is your mistake. That is, if you are looking at any measurement or your judgment is wrong, and then due to this nature of the observer, there is a faulty judgment. Right. You by the mistake you put another large amount of salt which you are not supposed to do it. Right. Similarly, imperfect techniques also, that I told you. Right. Similarly, parallax error. Right. It's also personal error. Right. Similarly, imperfection in experimental technique, I also told you what it is. It's very easy to understand. Next, second type other than systematic errors is random errors. Random errors is something which is not predictable. It happens due to nature's problem or whatsoever accidents happens. Those type of errors which cannot be rectified actually, because it is something which happens arbitrarily. You cannot rectify it. Next type is least count error. I just told you what is least count. It is the least possible measurable or least possible measurement which can be done by any device, and it changes according to the device. More precision device will be having least amount of least count. Clear? This type section is the type of errors itself, but in a mathematical way, right? How and all the classification is done. So as I said before, any values or any true value of any measurement is actually equal to measured value, right? The measured value plus or minus error, right? So there are different terms which you have to learn. Right. So first of all, let's say I'm going to take some readings. Say those readings are A1, A2, A3, A4, and it goes on AN. Right. Suppose this is suppose this is the 1.4 meter is the actual length of the piece of cloth. I'm going to take its measurement by any other measurement device, and I found values 1.39, 1.38, like that. So these are all A1, A2, and like that I'm taking this many readings: A1, A2, A3, A4, and AN. Right. So how would you take this? You would have done some science experiments, and what would you do after 5 or odd number of readings are done? You add them up, right? You find what is known as a mean value. So what would be that? It would be A1 plus A2 plus A3 and goes on AN whole divided by N. Right, so this A mean, right, then you would say you would have done an experiment. You would have made a table column like this, and at the last section you would have taken a lot of readings, and you would add them up, and then you will divide it by number of readings you've taken, and you will take this is the actual answer. Right, I hope you remember the Ohm's law, etc. You would have done by this method only. So this A mean is the actual value. So A mean is our true value. Clear? Right. So similarly, So first term, similarly, we have understood what is A mean, that is the average, right? So I can write it as summation of AI divided by N, and I changes from 1 to N, right? I1, then I2, like that till N. So this is a form of writing true value of any measurement or any length or any measurement of a device, right? So the second term which you have to learn in types or classification of errors is absolute error. Absolute error. This A mean is also known as true value. I hope you remember that. So what is an absolute error? And its symbol is delta A. Right. So what is absolute error, guys? And absolute error is usually in modulus. That means plus values. Right. Difference between each individual measurement and the true value is known as absolute error. I hope you don't understand. See, I'm having a value, see A1, similar A2, and there are AN. And for these values, I found A mean as their true value. So difference between each term, that is, say, delta A1. This is a symbol. Delta A1, that is the absolute error of the first reading, is equal to A mean minus A1, difference between the true value and the measurement or measured value, that is known as absolute error. So what will be delta A2? That the absolute error of the second measurement will be true value, how much deviation each reading is there from the true value. Similarly, what is delta A3? Delta A3, that will be measured value, that is, or I can say A mean minus A3. Right, goes on. What is modulus of A and nth values error? Absolute error will be true value minus its measurement. Right, clear? And third point, right, which is mean absolute error. That you can understand from the name itself. It is delta A mean. That is mean of these values, absolute error values. See, that is delta A1 plus delta A2 plus goes on delta AN whole divided by N. That is the mean absolute error. Or I can write in summation form as sigma I is equal to 1 to N delta AI by N. This much is clear. See, I'm just fast forwarding it. I will explain each of the things with a numerical problem, then you'll be very easily understood. Right. Next term which you have to learn is relative error. I hope you remember what is relative density. What is relative density? Density of the material by density of water. That is, you compare the density of a material with density of a standard value, that is density of water. Similarly, what is relative error is, you find a relationship of A mean, that is error, relationship of a error with the true value, right? Relationship of the error with the actual value. How much is the error percentage of the true value? That is known as relative error. And the fifth term is percentage error. That is, you are just multiplying 100 with the above section into 100. So I hope you understood just the term, just glaze it over. I will do with the problem, then you will understand. See, I'm going to take some readings, guys. I'm taking an example. I am using a scale to measure, a scale or a meter strip to measure gauges or a piece of cloth's length, and I had around 4 readings, and the first reading is A1 is equal to 5.2 meter, A2, that is the second reading, is 4.9 meter, A3, that is the third reading, that is 4.7 meter, and A4 is 5.2 meter. Like that, 4 readings I took. First, so what is a true value, guys? It can be between these 4 values, right? So how can I find the true values? When you take a readings, 5 readings or 4 readings, after that to find the correct value, you find the A mean. That is the first term. What should I do? I add all these terms A1, A2, A3 plus A4 whole divided by number of terms is 4. So you just add these guys, right? You will get the average as 5. I'm not going to do the calculation. 5.2 plus 4.9 plus 4.7 plus 5.2 whole divided by 4, you will get the value as 5. So what is the true value of the measurement of that growth pace? It is 5 meter. So you got the first term which we discussed earlier, that is mean. Clear? Now the second term which we discussed is absolute error, right? Absolute error is actually the difference between A mean and the each measured value. How much deviation is there or how much error is there for each measured value. That is your absolute error, and it is always positive. So see, delta A1 is the error of the first measure value. It should be more or less plus, right? So difference between these two guys is 0.2. So 0.2. What is delta A2? I didn't put delta. That is equal to difference between the true value and the measured value. That is how much error is there? 0.1. Similarly, delta A3 absolute is what? 5 minus 4.7 is 0.3. You can write 5 minus 4.7 or 4.7 minus 5. Why? Because you are putting it in modulus. So it is 0.3. Now delta A4 is difference between these two guys, that is 0.2. Right? So you found 4 absolute errors. Right? Error of each measured value from the true value, that is known as absolute error. Now third section is, what was it? Mean absolute error. That is mean of the absolute errors. How many absolute errors are there? 4 absolute errors. So you have to just add these. That is delta A1 plus delta A2 plus delta A3 plus delta A4 whole divided by 4. That is 0.2 plus 0.1 plus 0.3 plus 0.2 whole divided by 4. 0.2 plus 0.1 plus 0.3 plus 0.2 whole divided by 4. Right? You will get a value, I think it is quite close to 0.2 meter, because 0.2 is repeating, right? So the answer is 0.2 meter. That is your absolute mean. Right? You got the value like this? Any problem? No. Now we are going with this is, I am writing it as delta absolute mean error, right? So absolute mean error. Right? Now the fourth term which we talked about is what? Relative error. Right? Relative error. So what is relative error? That is delta A mean. Relationship between how much ratio is the error with respect to the true value. This is delta A mean, and what is the true value? A mean. Right. So what is delta A mean here? 0.2. And what is the true value here? 5. So 0.2 by 5, or I can write 2 by 50. Or it is 1 by 25 is your what? Relative error. And converting this relative error into percentage, that is, you just have to multiply 1 by 25 into 100. So it is 4%. That is known as percentage error. That is how much percentage is of the, or percentage value of the error is when compared to the true value. That means when you measured this cloth whose actual length was 5 meter, you made an error of around 4%. Right? 96% calculation was correct, but 4% error occurred. I hope you understood with an example. Right? Now it's very simple, guys. I'm not going to elaborate it much. So what we did is we found 4 terms with respect to error. First one is what? Each individual values, that is measured values. Average of those measured values is known as true value, or it is known as arithmetic mean or mean value. Now each values or measured values, how much it is deviating from the true value is known as error, and its actual name is absolute error. So absolute error of the first term, absolute error of the second term, and goes on. And the next third topic which you dealt with is the mean of these absolute errors. So mean means you just have to add these guys divided by the number of terms. Then there is relative error, the relationship between or the ratio between arithmetic mean of absolute error divided by true value, that is A mean, is known as relative error. That into 100, or the percentage value of the same relative error, is known as percentage error. This much is clear? Okay guys, then we will move on to the next topic in the next video.